Everyone, it's Tony from Archism again, getting ready to solve a few more kinematics problems. On kinematics problem number 1, we worked on distance, speed, and time equations, but this time we're actually going to be using the constant acceleration kinematics equations to solve the problems that we have in this video. So let's get started. So the problem here is, in the fastest measured tennis serve, the ball left the racket at 63.14 meters per second. A served tennis ball is typically in contact with the racket for 30 milliseconds and starts from rest. Assume constant acceleration. So, part A is, what was the ball's acceleration during the serve? And part B is going to be, how far did the ball travel during the serve? Okay, so part A. Since we know that this is going to be a constant acceleration problem, what we need to do is write down all the cake equations and figure out which one we're going to be. So we're going to use. So if you watch the deriving the constant acceleration kinematic equations, you'll remember that our first equation is going to be final velocity is going to be equal to v initial velocity plus acceleration times delta t. Our second equation is going to be delta x is equal to v, change in time, plus 1/2 a delta t squared. And our final equation is going to be final velocity squared is equal to initial velocity squared plus 2 times acceleration delta x. So if we're trying to find acceleration, we know that for sure all of these are going to work right now. We have our a here and we have our a here, but we're trying to find acceleration, and we're given right here time and our final velocity. So we're trying to look at which equation we're going to use that is going to give us that has both a final velocity and a total amount of time. So we know for sure that we're not going to be able to use our third equation because right here we don't have a time component, and so we know that since we're given a final velocity and we're given a time, we're going to be using this first constant acceleration kinematic equation. So for our final velocity is going to be equal to 73.14 meters per second. And our initial velocity, it says right here, and starts from rest. So we know that this tennis ball is going to start from rest. So we know that its initial velocity is going to be equal to 0 meters per second. So what we're trying to find here is acceleration. So we're just going to leave that as a times change in t. So we know it's 30 milliseconds. So we know that 1,000 milliseconds is going to be equal to 1 second. So this means that in order to convert from milliseconds to second, we're going to have to multiply this 30 milliseconds by 10 to the negative third in order to get seconds. So if you divide both sides by 30 times 10 to the negative third, you're going to find that your acceleration is going to be equal to 2438 meters per second squared. So 2,438 meters per second squared, which is a huge number. The ball accelerated from 0 to 2,438 meters per second squared in only 30 milliseconds, which I think is pretty impressive. So on to part B. Let's write down all of our cake equations again to see which one we're going to use. So if you remember from the last slide, final velocity is equal to initial velocity plus acceleration times delta t. Our second one, delta x, is equal to v, change in delta t, plus 1/2 a delta t squared. And our third one is final velocity squared is equal to initial velocity squared plus 2a delta x. So we're looking for how far the ball traveled. So we know that we're going to have a delta x component in whatever we're going to do. So that immediately we're going to eliminate our first cake equation. So we're left with our number 2 and number 3. We're also given our final velocity, and we also have our acceleration from our last problem. So if you remember that was 2438 meters per second squared. Um, and we also have our initial velocity right here. So if you look at it, you can use either way that you want, but I want to use the way that's gonna be the least amount of dividing for me. So that means I want to use K2. For this problem, it would work if you use either equation, but I'm just gonna use this one. So delta x is equal to uh, our initial velocity, so 0 times 30 times 10 to the negative third seconds, plus 1/2 times our acceleration 2438 meters per second squared times our uh 30 milliseconds. So, sorry, 30 times 10 to the negative third seconds squared. Don't forget this squared right here. That's part of the equation too. So if you plug that into your calculator, you're gonna have your delta x as equal to 1.10 meters. So this is how far the ball is going to travel over the time period where it goes. This is not the total distance that the ball is going to travel in total. You have to remember that this is how much the ball travels during its acceleration, accelerating from that 0 meters per second, all the way to that huge number of 73.14 meters per second, which I think is also very impressive over that small distance. Okay, thank you guys for watching. Remember, if you have any questions, please email us at archismgroup@gmail.com. And as always, like and subscribe, and thank you for watching. I'll see you next time.